Hello everyone, this is Martha from the Academic Support Center, and this is a video on trigonometric equations and how to solve them, geared towards Pre-Calculus 2 students. Okay, to start off, a trig equation is anytime we have any trig function and it equals something, and we need to find what that x is. So a couple of helpful tips. The first goal is to isolate everything on one side, and there are a number of ways to do that. We can do that, with algebraic adding or subtracting, multiplying or dividing, and then we can also set it equal to 0 if we have something squared and sine and then a constant. Sometimes we can factor this out and solve it just like we would with the quadratic equation. Also, we can use our trig identities. We can use the Pythagorean identities, half angle, double angle, any of those work. And something to keep in mind is that sometimes there are multiple answers. If we look back at our unit circle, that sign, whatever, if we get a sign and it's, let's say, where sine is 1/2, right? That corresponds to the angle pi over 6, but also 5 pi over 6. And so remember that there could be multiple answers for those angles. And just a quick review, we're going to look at that unit circle and we're going to say, okay, when is sine positive, when is sine negative, when is tangent positive? This is just something that if we get an answer of -1/2, we need to know which quadrant we're looking at. So let's start off with cosine, or x values. Cosine is going to be positive in quadrant 1, negative in quadrant 2, negative in quadrant 3, and then positive again in quadrant 4. Sine, our y values are going to be positive in quadrant 1, positive in quadrant 2, negative in quadrant 3, and then negative in quadrant 4. Now tangent, that's important because tangent is going to be positive in quadrant 1 because we've got a negative over a positive. In quadrant 2 it's negative. Now in quadrant 3 we end up with a negative over a negative, so tangent is positive in quadrant 3. And in quadrant 4 we have a negative over a positive, meaning that it's negative. So as we solve answers, we'll need to, as we solve and get answers, we'll need to remember how to narrow it down within the interval that we're given. So our first example, we have the equation 5 sine of x equals 3 sine of x plus 3. And this is one where we can use algebraic manipulation. Oh, also we're given that the interval is the interval for x is between 0 and 2 pi. So 5 sine x equals 3 sine x plus square root 3. This is one where it's fairly straightforward. We can subtract 3 sine x from each side using a little bit of algebra, and we get 5 sine x minus 3 sine x is 2 sine x equals square root 3, and we divide by 2. And we get that the sine of x is equivalent to square root of 3 over 2. So if we look at our y values, where are those square root of 3 over 2? And that is going to be at this first 60-degree angle, or pi over 3. And then it's also going to be at 2 pi over 3. Or 120 degrees. Some people like to think of doing like arc sine or sine inverse to each side. To me, I just like to think of it, okay, when is my x equal to that value? Or when is my sine, the value of sine, equal to that value? Now for our second problem, we have 2 cosine squared x plus cosine x minus 1 equals 0. And this is an instance where we can factor out and set equal to 0. So what I'm going to do is a little bit of math sleight of hand. I'm going to say that u equals cosine x. And I'm using u because sometimes it's easier to see patterns where we can factor things out when we have letters instead of cosines. So if we rewrite our equation using u as cosine x, we get 2 u squared plus u minus 1 equal to 0. So from here, we can factor out using the AC method, but I prefer by grouping. And so I'm going to say 2u squared plus 2u minus u minus 1. If I add these two terms together, I still get that plus u. Then I'm going to take my first group and I'm going to say, what can I pull out of these? And it's 2u from both terms. And I'm left with u plus 1. If I look at my second, I need to match this u plus 1. And if I pull out a negative 1, I'm left with u plus 1. I can then factor out my common term of u plus 1, and I'm left with 2u minus 1, and then u plus 1. And all of these are equal to 0. I take each of these terms and then set them equal to 0. But first we're going to put this u, we're going to put cosine back in. So we get 2 cosine x minus 1 equals 0, and then cosine x plus 1. We're going to set these terms equal, each of them equal to 0, and solve for them. If we take 2 cosine x minus 1 and set that equal to 0, if we add 1 to each side, we get 2 cosine of x equals 1. We divide by 2 and we get cosine x equals 1/2. Now if we look at our unit circle, where is our cosine 1/2? We have that here at 60 degrees, or pi over 3. We also have cosine positive in quadrant 4. And so we're going to come down here and we have the cosine of 1/2 for when the angle is 5 pi over 3 as well. So those are two of our answers. We're going to take our next factor and set it equal to 0. So we get cosine of x plus 1 equals 0. If we subtract 1 from both sides, we get that cosine equals negative 1. Cosine equals negative 1 over a pi. So our answers are x equals pi over 3, pi, and 5 pi over 3. All right, for our last example in this video, we have the equation 2 cosine squared x plus 3 sine x equals 0. So this is an instance where we have sine and cosine mixed together, and that's going to make it really difficult to solve. But we can look at our problem and say, is there a way that we can use one of our trig identities to make this solvable? And if we take the Pythagorean sine squared plus cosine squared equals 1, we can solve for cosine squared and put that in. So let's subtract sine squared from each side, and we get that cosine squared equals 1 minus sine squared. And so that is what we're going to put in place of this. So let's give that a try. We've got 2 times 1 minus sine squared plus 3 sine, can't forget the x, equals 0. So first we'll distribute. That gives us 2 minus 2 sine squared x plus 3 sine x equals 0. Rewriting it, we can say, let's do negative 2 sine squared x plus 3 sine x plus 2 equals 0. From this, it gets a lot easier to factor, especially if we do a little trick here. Because with factoring with a negative out front, it can be kind of difficult. But if we multiply each side by -1, we're keeping that equation balanced. And our result is 2 sine squared x minus 3 sine x minus 2 equals 0. And this becomes a lot easier for us to factor. The right side stays 0 because 0 times anything is 0. So now let's factor this out. And for the sake of time, we're just going to jump ahead. And this factors into 2 sine x plus 1 times sine x minus 2. And if this is confusing about how we got there, or if it's too much of a jump, feel free to pause the video and give it a try. So we set each of these factors equal to 0. So we're going to take 2 sine x plus 1 equals 0, and then sine x minus 2 equals 0. So if we take the first and we subtract 1 from each side, we get that 2 sine x equals -1, and then we divide each side by 2, we get that sine of x equals -1/2. Now because sine is negative, we know that we're going to be in quadrant 3 or quadrant 4. So we're going to narrow those down. And then with sine, for the second factor, sine minus 2 equals 0. If we add 2 to both sides, what we get is that sine of x equals 2. But this is not a valid solution because the sine is always going to be between negative and +1 on the interval that we're given. So make sure that when you get your answer to make sure that the sine is valid, or the cosine or the tan is valid within the interval that we're given. So now we're going to go back to the unit circle and say, okay, when is sine -1/2? And if I look at my unit circle, I know that it's 7 pi over 6 and 11 pi over 6. And so I know that x equals 7 pi over 6 or 11 pi over 6. I hope this was helpful. Have some fun and get in some practice. Let us know if you have any questions.